Greetings, traveler. Recently, a traveler named Danislav Petrov asked me what would be the best way to learn math for game design. His situation is that he has a bachelor's and master's in psychology, so he feels that he has some good understanding on that topic, which is of course very useful for game design. But on the math side, he feels that he wants more skills. So he wants to know more specifically what to study, where it is useful, and so on. So today what I'm going to do is I'm going to talk about my motivation for learning math, not just for game design, but for playing games in general. I'm going to give you the hard way of going about it as I experienced it, and then I'm going to talk about the easy way of handling it and what are, according to my experience, the three most useful topics in mathematics for game design. My name is Xanthos. I've been working in the games industry for over 13 years now. And even before that, when I was just playing games, there came a moment in many of the games I played where I was wondering, how can I do more damage with my class, with my character, and so on? Whether it was playing MMOs and I was trying to be a good damage dealer, or I was playing something like Monster Hunter and I wanted to make a choice between all the available options for weapons in the game, that question somehow kept coming back to me. So I think the moment that I remember most clearly where my mind made the switch from just playing a game randomly and going with whatever comes my way in terms of choices for weapons, the game put this very interesting choice in front of me. I had the materials to make my next weapon, but instead of having one choice, the game gave me three choices. So I had version A of the weapon, which was something like high base damage, version B of the weapon, which was I think lower base damage but more critical, and version C of the weapon was low base damage and critical but high elemental damage. So I was sitting there thinking, which one? Which one should I choose? Which one is better for hunting all the other monsters that I need to hunt from now on? And I realized that I had no method of selecting. I didn't know what damage meant in exact terms. Of course, Monster Hunter is a game that purposely hides the hit points of the monsters and all these things. Well, recently it's changing, but back then all these things were supposed to be a bit mysterious, but even so, I wanted to know. So what I did back then was go online, find in forums the exact damage calculation formula for Monster Hunter. And then the next topic was what weaknesses monsters have, what's the meaning of normal damage versus elemental damage, how often criticals happen in the game when you do score a critical, how much more damage you're supposed to do. Was it like 25% more, 50% more, 2 times, 3 times? I just didn't know. I just thought criticals are good. So in order to make an informed decision, I had to find out exactly the calculation formula. And then even when I did, I still had the question in my mind. So when you're thinking about a critical, are you going to think about the case where you do score the critical or when you don't? Do you take the critical case as your base damage or the one where you didn't score a critical? And how do you calculate that over time? Do you assume all your hits are critical hits or just some of them, or do you take the average? I had all these questions, and of course there's no one answer even in that situation because everybody has a different playstyle, and depending on what weapon you're using and what monster you're going for and what area you're targeting, there's all these parameters in that game. But I still had to make a choice because I only had materials to make one of these swords. So that's when, for the first time in my life, I realized that math is not just useful, it's fun. It's fun to learn about these topics, and it's fun to be able to use this knowledge to do better in the game I was playing. This had tangible value for me. So that was the motivation I had, and that was such a stark contrast to the hard mode of dealing with this topic. What was the hard mode of this? Going to school. and going to university. I did a lot of years of both. I was exposed to a lot of math in those cases, but other than the absolute basics, so addition, multiplication, subtraction, and division, I didn't really remember anything from school. So I must have had like a solid 10 years of mathematics that my brain simply did not retain. So I have no idea how I passed the tests, but I talked about before how the Zeigarnik effect kicks in, and basically the moment that piece of information stops being useful for the brain, also known as the moment where you pass the exam or the exam finishes, the brain just wipes it all out, and you don't even remember it anymore. So that definitely happened to me with all those 10 years of mathematics. So if somebody was looking to learn mathematics for game design, starting right now, I would not recommend going to a big scary school of math or whatever it is. That's what I did, and personally it did not work at all for me. It was a catastrophic waste of time if I had to put a label on it. And I think the reason for that is because there's no application, right? You're shown all these things and maybe they're useful, but you don't know what to do with it and you forget it. Just like a language you learn for 2 months and you never use it, yeah, you will forget it. It's just the way the brain works, I guess. So that being the hard mode, let me bring in my trusty whiteboard and show you what the 3 topics I think are more useful in math are. So the first topic is, of course, the basics. I think most people know this, so I'm not going to spend too much time on it, but addition, subtraction, multiplication, division are something well, not just for game design, I think for life. It's pretty basic. So that is definitely useful. Any knowledge you have around these operations is just going to make your life massively easier. So that goes without saying. It's my first recommendation. So the second sort of category after the basics is definitely, I think, polynomials. So if you've solved any equations of the type x equals something something, or find x given that y is so and z is so and so on, these are the kind of operations that I find very useful, mainly because they teach you how to basically solve for unknowns. It very often happens in games, not just in game design, but in game production as well, that you only know some of the parts of the equation and you need to figure out the others. So if you need, 10 characters in your game and each character takes 1 month to develop, how many months do you need in total? That sort of very, very basic stuff. Of course, that's the most basic version of it. There's much more complicated versions you can learn with this and enjoy its application, but looking into polynomials I think is very, very useful. The next one is number series, and that is all the knowledge and theory that comes with consecutive numbers that have all some set relationship with the previous and the next member in the series. So something like the Fibonacci numbers might show up in this kind of knowledge. So where is this useful? This is not a topic that I would say you need to study to its very end and know absolutely everything about, but I found it useful personally when I was thinking about progressions. So levels, how much XP you need to get to the next level, how much damage increase does one weapon have when you level it up, how many items does the next level enemy drop. If the level 1 enemy drops 3 iron ingots and the level 2 drops 5, then how much should the level 3 enemy drop? Of course, these are things that you can later on tweak at the game balancing step, but having a starting point, let's say trial size, a trial series, so to speak, to get started with, gives you a starting point. It's better than having a blank sheet of paper and thinking, how many iron ingots do I want to drop at level 17? It's much easier to have a base value and then adjust from there more or less as you need. So that's the second one I would recommend. Logic operations is the third one. So if you've seen anything like if A is true and B is true, then C is false, for example, any sort of logical relationship between values like that, I find useful for game design. Because in game design, often we have to check game states. So you might have to do something like if player has key and door is locked, then player can unlock the door, for example. All these conditional checks. Or if the player has status poison and you use antidote, then the poison status is removed. All these things, can work based on logic. It's not necessary that you use logical operations to check for these things, but it's one way to go about it. Again, unless you know a better method or unless you want to use something different for this, this is a good place to get started. And logical operations are used in code a lot as well. So that's the third topic that I think that's in this second tier of a bit more advanced and a bit more nuanced mathematical topics that are very commonly used in game design. And for the third, for the more advanced cycle, I would definitely go with statistics. So statistics are not directly related when you're creating something in game design, but they're more closely related to understanding it and analyzing it. So for example, I spoke before about criticals and how often their damage comes into play and how much of a damage increase can you expect over time, given that you increase your critical chance probability by, 10% or something. So to make these evaluations and decisions for bigger sets of data, that's exactly what statistics is meant to solve. And not only it comes useful very much so in game design at the design phase, but it is extremely useful when you're trying to analyze and understand the behavior of players in the game. So if you know, for example, that the average player spends, 2 days in your game, then that gives you an understanding of what players do in your game, how long they stay, around which point they quit, or if you have many areas in your game, with this way you can measure which areas are more popular, you can create heat maps, you can get this sort of understanding over data with statistics. And if you take it that far, then I really recommend common factor analysis, because that theory shows you what are some of the common things of a certain group. So for example, let's say that you have 1,000 players in your game right now, and 100 of them are playing for a really, really long time, and everybody else quits the game after, 1 hour or something. So clearly there's some difference in behavior between those two groups. So in that situation, what you might want to do is make the rest of the people that don't play the game so long play as much as the really engaged players. And one way to go about it is to take a closer look at what the engaged players do. What are the actions that those guys do that give them so much enjoyment that they want to keep playing the game way longer than everybody else? So you might find that they took a different route through the game, or you might find out that they played a certain class in the game, or they had a particular difficulty curve that made it easier for them to play the game, and the game perhaps wasn't so punishing for them. So they felt that they have a fighting chance in the game, and they kept playing. Whatever it is that those more successful players in the game did versus everybody else, having an understanding of that is going to help you design the game in such a way that more of the people can have this really, really fun experience and they want to play your game for longer. So this is a theory that I found that helped me a lot when I was analyzing the behavior of players in my game. And since you made it so far, let me also give you a bonus topic. So for those of you who are more technically minded and want to have a better understanding of the movement of objects in space, whether it's 2D space or 3D space, I would highly recommend geometry. This is useful when you're thinking about the distances between things and how things move. So let's say you are trying to calculate the range of an attack, or something like, you know, when some player comes into a certain zone, they get affected with a specific status effect. Having an intuitive understanding of these distances and how they change the player's experience, if you're making that sort of game, I think is very, very useful. So having an understanding of how far everything is from each other, and moreover, if you're making a 3D game that, or even a 2D game that has acceleration and speeds and the rate of deceleration, maybe you're making a space game or something, having an intuitive understanding of space and the math around space. Of course, physics comes into this, but again, that's the nature of game design. Every body of knowledge out there is relevant to game design. So it's so difficult to confine it to just a few topics, but let's just take these first and then expand from that. So if your game is in 2D or 3D space, which most games are, having some understanding of how things move in the game and how far everything is from each other is going to be very useful. Geometry is something that looks at that. Also, if you're looking at angles and if you're more on the programming side, you're coding the game, you're trying to make movement speeds and turning angles and so on, trigonometry is also going to be very useful in my experience. So if you want to go a bit further than pure game design and venture into coding your own NPCs and how they move in space, this might be an interesting topic to look into as well. So to wrap it all up, my motivation for all this was entirely selfish, entirely game driven. I just wanted to do more damage in games, that was all. And because I had a point where I could use math to gain a reward in game, it made me want to learn more and more about it. And by the time I used it in game design, it was just fun to research these topics and learn them on my own. And if you want to know a bonus fact from my experience, I learned all these things extremely fast. So normally all these topics are semesters in school or university or whatever. I learned these in days. It was scary how fast I learned these things because I had a specific application for them. And whether I learned it from a website or a short course or a YouTube video or something, I already had in my mind the application for this knowledge I was seeking. So it was very easy for me to understand if the video I was watching, for example, for math, was relevant or not. So I could get a very intuitive understanding of these things in a matter of days, if not in a matter of hours. So I don't know what that says about our education system, but yeah, maybe that's food for thought. Anyway, I hope this helps you. I hope this sets you off in your journey to learn math and see that it's actually pretty useful to life. We just need to have a way to use it in our real life to make it meaningful. Thank you so much for your time, and as always, have fun.